So let us continue now our lesson, reaching section 4, which is entitled Arrays as Pointers. Let us recall arrays as we know them until now. We can declare an array using the square brackets syntax following the variable name. For example, int x 5. X is an array with 5 elements. They are indexed, of course, from 0, 0, 1, 2, 3, 4. You must include the size inside the square brackets unless you are also initializing the array. Also, you can provide the size and provide the initialization value. And note here that this is only valid the equal curly braces and element list, the curly braces comma separated, is only valid for declaration, and the size can be greater or equal to the number of items. I can declare an array of 7 elements and I give the initial value of the first 5. So the remaining elements remain uninitialized. You can access the element using the square bracket syntax became -3. And also, as I recall, arrays can be passed as parameter. The type being received would be denoted as int x square brackets and they are empty, of course. And for example, void print array, you pass an array and of course you pass its size along with it. Pointers and arrays have a close relationship. If I declare x of 5 elements equal 1, 2, 3, 4, 5, what we have told you that you can represent it as follow: x with an array index from 0 to 4 and containing the 5 elements. However, a variable declared as an array of some type acts as a pointer to that type. When used by itself, it points to the first element of the array. It means the reality of this schema is as follows. X is a pointer which points to the first element of an array of 5 elements. So this is the real schema. If I can also declare a pointer p of base type int, and I can make the assignment p receives the value of x. So I have this schema. P is a variable of base type int, and p also shares the same pointy as x. A pointer can be indexed like an array name. You can use either x, either p inside the array syntax. So p now is set to the address of the first element in x, and for example, to access the third element in x, which we accessed in the previous slide, we can either write x of 2 or dereference p plus 2 because this is p and we advance 2 elements of size int, okay, and then we dereference, or we can either write p of 2 or dereference x plus 2, and we can put the -3 value inside it and it will stay valid. So, equivalent syntaxes, as we wrote before, I can write p of I. It is equivalent to writing dereference of p plus I between parentheses, and the address of the element at p of I is nothing but p plus I, because you put the address for the dereference and they are complementary operators. So this is the array syntax and this is the pointer syntax, and they are equivalent. So, are they exactly the same, p and x? Are they exactly the same? No, they are not the same. An array variable is a constant pointer. Here, x is a constant pointer. The value of x cannot be changed. However, the value of p can be changed. So, I put here a tag to remind you that the arrows that exit from x cannot point anywhere else. This blue arrow is fixed, it cannot change. You cannot write in C a new variable in the memory and then let x point to C. This is wrong. You declared x as an array, it will point always to the first element of this array. So also it is wrong to increment x. X++ is also wrong, will lead to compilation error. However, p is free to change its value. He can increment p or decrement it to point the next integer or the previous integer inside the array. So here we say that p is a pointer that iterates the array. So here comes the nice things we can do with pointer syntax. Suppose you want to add the value 1 to each of the elements of the array. And suppose that this is your array, int x equal 1, 2, 3, 4, 5, int star p equal null, int I, and int size, in which you put the size of the array x. You can do the requested task using the usual way, using the classical way, the array syntax. You take for I equals 0, I less than size, strictly I++, and you say x of I incremented by 1. This is the classical way. And now let's see the way 2, which is the pointer syntax, which is also called using the pointer arithmetics. In here, you don't take the index I, you iterate your array using your pointer p. So for p equal x, you initialize p to be equal to x. P, when do we stop? When p becomes greater or equal than x plus size. So this is here at the end of the element x plus 2, plus 3, plus 4, and plus 5. So this is x plus 5, and as long as p is less strictly than x plus 5, we increment p plus plus and we do the iteration, and we dereference p and we post increment it. So we do for p equal x, we increment 1 to 2 for p plus plus, and then we dereference p and we increment to 3, and then we increment p to point the next element and to dereference it and increment it itself. So here p plus plus and dereference p plus plus. So and so on until p reaches the end of the array, in which case the condition is not true anymore and we exit the loop. Let us notice this here. Dereference p between parentheses and plus plus, which this syntax we used in order to increment the elements inside the array, and it replaced the x of I plus plus. So what if I change the place of the parentheses? Does the meaning change? Yes, it changes. Dereference p plus plus means increment what p points to. However, dereference p plus plus means increment p, increment the pointer to point at the next array element, and then dereferences it to get the content. What to do with the content? Increments p, but the content is not. If you said dereference p plus plus equal 4, you have put in 4 inside the next element where p points. What does each of the following do if I remove the parentheses? Dereference p plus plus. Who wins? Does the parentheses here come or in the second statement? In order to decide, we need to consult the table of precedences in C. We see in this table that the postfix operators plus plus and minus minus that come after the operand, they are the postfix, have precedence over the unary operator, which is the dereference and the ampersand reference operator and all the other unary operators, and that the postfix operators are evaluated from left to right, and the unary operator is evaluated from right to left. So let's consider an example and let's see how to proceed. Consider this main program in which we have an array x, and now we know how to draw an array x equal 1, 2, 3, 4, 5, and this is the screen because we want to see what will be printed on the standard output. So if I say int p equal x, p receives the value of x, which is the address of the first element in the array. If I say printf %d dereference p++, who will win? This is the question. The plus plus will win. The p will be incremented, but it will be post incremented. So it will be post incremented, and before the post incrementation, we will get the value of the content of p. So 1 will be printed, and then focus a little bit, p will be post incremented. Okay, so we get the value and then we increment p. Let's suppose we want to print now dereference plus p. Who wins? The table of precedence says that we will proceed from right to left. From right to left, it means this is p here. We increment p and then we dereference it and give the value. So we increment p and then we dereference it and print the value. So this is very important example. And then let's suppose there is an instruction in which we have another version of the syntax, printf %d dereference p. They have the same priority, so we evaluate them from right to left. So we dereference p and then we pre-increment it. So this value 3 becomes 4. And then let's suppose we want to make sure what is the array values now. We do a for loop in order to print the array. It will print for sure 1, 2, 4, 4, 5. As examples, take the functions in the library string.h. We will revisit them in the section when we talk about strings and array of characters. But consider this syntax writes a string to the standard output device, one character at a time. This is the array syntax you take for int t equals 0, s of t is different than \0, plus t or t++, and then in the for loop you put putstr s of t. We could have written it in another way. Another way to write the same thing is to use the pointer syntax. Now you know that this is a pointer *s, and while dereference s is different than \0, so we can simply write while dereference s, putstr dereference s++. So you put the value of the dereference of s and then you post increment as we have already explained. Exercise for you to do is now to apply the same thing on this exercise and to apply the pointer syntax in order to see what will be printed in order on the screen. As a last part of this section, we will talk about passing arrays as parameter into function, because this is very, very important and you need to be sure of your knowledge. When declaring parameters to functions, declaring an array variable without a size is equivalent to declaring a pointer. In between the function parentheses, the parameter list, there is always the array is a pointer. There is no array. When what is being passed is a pointer to the array. This is the reality. In the formal parameter list, you can either specify the parameter as an array or as a pointer. No difference. You write int *x or int x brackets, it's the same thing, exactly the same thing. Often this is done to emphasize the fact that the pointer variable will be used in a manner equivalent. So let's take an example before we end this section and we pass to the next one. Write a function arraySum which returns the sum of a given array of integers. So we will begin array sum test. Of course, we will call the void function arraySum test, and we will write it here, and inside which I will declare an array x. I will print f the sum is %d \n, where %d refers to arraySum of x, comma, its size goes with it whenever she goes. So we have to write array sum, which takes a pointer x or a pointer a, and it's the size of this array pointed to by a. And then we can directly decrement size times. So for nothing as initial value, for size is strictly greater than 0. When it reaches 0, I will stop. And size is decremented while a will be incremented. How nice! And then I will say I have to declare a variable s in which I put the sum. So int s equals 0. So here I will say s plus equal dereference a. This is the pointer syntax, s plus equal dereference a. And finally I will return the value s, which stores the sum. So let's run our program, and here we have the sum is 114. So this is our program copy pasted here, and here we are inside the memory state. We want to trace what happened. As usual, the function call is here arraySum. We passed x to int a, int star a. So int star a received the x variable of the arraySum test, and the int size of the arraySum received the variable size of the arraySum test. So let's see in the memory what happens, and it points exactly where x points, and the variable size receives also the value of size, which is 4. And now we go to the program inside to see what does arraySum do. It initializes s to 0, and it iterates decrementing size, incrementing a, and accumulating the content of a into s. So let's do this. Size equal 4, s equals 0. So inside s, put s plus dereference a, which is 12. So now s will become 12, and size will be 3, and a will be incremented to the next address. Now s will receive s12 plus 23, which is equal to 35. Size will be decremented and a will be incremented. Again, s will be equal to 35 plus 34, which is 69. Size will be decremented and a will be incremented. And then last, size will be equal to 69 plus 45, which is 114. Size will be decremented and a will be incremented, in which case now size will reach 0, and we will exit the for loop with s equal 114, which will be returned to arraySum test, which will print this value for on the screen in the sentence the sum is 114. So this is our solution, and we have visualized the memory state preceding this solution, and now we can understand better how arrays are represented in the memory and why they are passed as addresses and not as whole arrays. Next, we will see a very particular kind of array, which is the arrays of characters, and we will compare them with the strings. There is no string type in C, but the string, we refer to string by char star, and we will see the difference between char brackets and char star. This is a very important section, and you have to be careful dealing with arrays of characters. So see you next time.